How's it, grade 12s? Today we're going on to converting one interest rate to another. Now, when would we use this type of formula? Well, you would use it when your payment period doesn't match with the interest compounded period, okay? So, for example, let's say payments are made every quarter, but your interest rate is compounded monthly. So what you would do there is you would convert the monthly rate to a quarterly rate so that both the interest and the payment periods are the same, okay? And you would use this formula over here. This formula is not given on the formula sheet. It's something that you need to know off by heart, okay? So if we have a look at a first example, and don't worry about me not writing it down. I'm going to upload the notes so you have them all there. Okay, I'm just going to read it out to you. It says, convert an interest rate of 18% per annum compounded monthly to a quarterly rate per annum compounded quarterly. Okay, so we want to convert a 18% compounded monthly to a quarterly rate. All right, so I'm going to use this formula here. And our M and our N relate to the compound periods. So the one would be quarters, which would be 4, and the other one would be monthly, which will be 12. Okay, so we've got this 1 plus I4. Now this is not saying I to the power of 4, it's just saying a quarterly interest rate. And our M is 4 to the power of 4 equals 1 plus I12 over 12 to the power of 12. So basically what I'm saying here is I'm changing a quarterly interest rate, or I'm converting a monthly interest rate to a quarterly interest rate. Okay, so now I'm just going to substitute all my values in. So we get here 1 plus I4 over 4 to the power of 4 equals 1 plus. Now, they told us that we have a 18% per annum compounded monthly rate. So I'm going to convert that 18% into a decimal. So it'll be 18 over 100. So we get 0.18 over 12 to the power of 12. Okay. So grade 12s, I'm going to skip a few steps here, but I'm going to show you on the calculator what I'm doing. So I'm going to do this on the calculator. We've got 1 plus 0.18 over 12 to the power of 12, and we get that. I'm now going to take the fourth root. Okay, then I'm going to subtract 1. Then I'm going to multiply by 4. And we get that I4 is equal to 0.1827135. I just multiplied by 100 to get it into percent. And usually the question will say round off to 1 decimal or 2 decimals. In this case, I'm just going to round off to 1 decimal. So we get an interest rate of 18.3% per annum compounded quarterly. Okay, so we have converted an 18% per month rate to a 18.3% compounded quarterly rate. All right, so let's have a look at it in terms of a question where you have a loan or you're saving or something like that. Okay, so example 2. Example 2 is saying 1,000 Rand is invested every month into an account paying 16% per annum compounded semi-annually. The first payment is made on the 31st of December 2000 and continues thereafter for a period of 10 years. Calculate the future value of an annuity at the end of the investment period. Okay, So we've got a bit of a problem here because this person is paying every month, but your compound period is semi-annually. So what we need to do is, before we even get into answering this question, we need to convert that semi-annual rate to a monthly rate. Okay. So I just want to make a note here. So we've got that our interest rate is equal to 16% per annum compounded semi-annually. Okay, and our payments, I'm just going to say it's X, our payments is monthly. So you see the problem here, we've got a semi-annual rate for the interest and a monthly rate for our payments. We're going to make them the same, so I'm going to use our formula that we've just learned. So we're going to convert it into a monthly rate, so that's I12 over 12 to the power of 12 equals 1 plus, now we are given a semi-annual rate, so that is going to be 2 over 2 to the power of 2. Okay, so 1 plus I12 over 12 equals 1 plus, now this is going to be 0.16 over 2 to the power of 2. All right, so grade 12s again, I'm just going to miss a few steps here, and I'll show you what I'm doing on the calculator. So we've got 1 plus 0.16 over 2 to the power of 2, and we get that. I'm now going to take the 12th root of that, subtract 1, multiply by 12. Okay, so now I've got it into an interest, or not an interest yet. I just have to multiply that by 12. Okay, multiply it by 100. All right, so I'm going to round this off to 1 decimal place. So we get here I12 is equal to 15.5%. And now this is per annum compounded monthly. Okay, so now we're ready to answer the question. I'll read the question again to you. It says 1,000 Rand is invested every month in an account paying 16% per annum, compounded semi-annually. The first payment is made at the end of the month, which is the 31st of December, 2000. And this goes on for 10 years. So, because we're paying at the end of the month, we've got that additional payment because they'll obviously pay right at the end as well. So just keep that in mind when we calculate our N. So F, we don't know. That's what we're going to find out because this is an investment. Our monthly payment is 1,000. Our interest rate now is over 100. And our time period is 10 years. And we have to multiply that by 12 to put it into months. But I'm going to add 1 to it because we've still got that payment at the end of that month. Okay, so we get here 121 payments. Okay. Right, so now what I'm going to do is I'm now going to, and we just need to divide this by 12. So let's work that out. We get 15.5 over 100. Divide that by 12. And we get, I'm going to leave it as this. 31 over 2400. Okay. So use our future value formula. F is equal to x 1 plus I to the n minus 1 all over I. Substitute our values in. To the power of 121 minus 1 all over 31 over 2,400. Okay, if we put that in the calculator, we will get a future value of 288,248 Rand and 17 cents. All right, moving on to the next thing, grade 12s, is converting an annual effective rate to a nominal rate. So with this type of thing is you have your nominal rate, and your nominal rate is normally what they say in the question. For example, that previous one was, they told us that it was 16% per annum compounded semi-annually. That is your nominal rate. Your effective rate is the interest that actually does the work on your investment or on the loan, okay? And we can convert between the two. So for example, EG3. Now this formula again is not given to you. You need to know it, all right? So example 3 is saying convert a rate of 18% per annum compounded monthly to an annual effective rate. So we have our nominal rate, 18% per annum compounded monthly, but we want to find out what is our actual effective rate for this per annum, okay? And we use this formula here. So 1 plus I effective is equal to 1 plus I. Now, our M here, because this is compounded monthly, is going to be 12 over 12 to the power of 12. Okay, 1 plus I effective is equal to 1 plus, convert that, so that's going to be 0.18 over 12 to the power of 12. And I'm going to miss a few steps here, just put everything on the calculator for you. So we get 1 plus 0.18 over 12 to the power of 12. I'm now going to subtract 1, and we get that. What I'm going to do now is I'm going to multiply that by 100 to get it into a percent. And we get the effective interest rate is 19.6% per annum. Okay, so an 18% per annum compounded monthly rate would give you an annual rate of 19.6. All right, thanks grade 12s.